This is lesson 1-5, angles, angle bisectors, and angle addition. So we're going to start with some basic angle vocabulary, and then our angle bisectors and angle addition are going to follow from our segment bisectors and segment addition. So we're going to see some similar concepts from stuff we've already seen previously in Unit 1. An angle is the intersection of two rays at a common endpoint. And our symbol is like a little angle here that opens to the right. Just like with the points, lines, and planes, there's lots of ways to label, and we do have to be very specific. So we can label the angle symbol with 3 points, making sure the vertex is always in the middle. The angle with just the vertex. Now, you can only do this if there's only one angle with that vertex, or you can do the angle symbol with a number if a number is given. And before we look at the examples, I do want to move into the next vocab word, which is vertex, because that is used in the angle definition and how we label. The vertex is the point at which the sides of an angle meet. And so you can think of the word V for vertex, and then that point where the two sides meet is the vertex. So if we look at this example, our two sides are the rays, like it talked about in the first example, and then they are meeting here. So point A is the vertex. If we look back up here now, the sides, it says it's two rays, the intersection of two rays. So this would be ray AC, and this would be ray AB. And then they meet at the common endpoint, the vertex, like we had talked about below, which is point A. So we have a few ways to name this. So first, we have a number provided. The number will always be inside the angle, kind of close to the vertex. So we could call this angle 1. We could also name it with the vertex because there's only one angle here and call this angle A. The other option is the 3 points, making sure that the vertex is in the middle. So angle CAB, C to A to B, or similar to lines, the order is not important. If you went B to A to C, that would be fine too. The important thing is that the vertex is the middle point there. Then we have some types of angles. An acute angle has an angle with a measure greater than 0 degrees and less than 90. So I like to think of the word cute, and usually we think of small things being cute. So these are our small angles, like puppies or kitties or things like that. So an example is, let's say this angle was 25 degrees. That would be an acute angle. Now, a right angle you should be familiar with. This is an angle whose measure is exactly 90 degrees. So this box means we have a right angle and we have a 90-degree angle. An obtuse angle is an angle with a measure greater than 90 and less than 180. So if this angle, angle A, were 130 degrees, that would be an obtuse angle. And then our last angle classification is a straight angle. And it has the word straight here. You need to get a straight line. And this is an angle that is 180 degrees. And so we would typically see a measurement like this to indicate an angle in 180 degrees. So for a straight angle, we need to get a straight line. So as your 4, they kind of go smallest to biggest. Name the following angle 3 ways. So there's only one angle here. So our first option is to just use the vertex, which is here where the sides meet, and call this angle O. The second option is to use the 3 letters, the vertex in the middle. So angle NOP, again, making sure the vertex is in the middle. And then the final way would just be the reverse order, again, making sure that the vertex is in the middle. So angle PON. Then we have a more complicated diagram here that we're using for questions 2 and 3. Question 2 says, name the vertex and the sides of each angle. So angle 5 is the first one. The vertex is that point where the sides meet, and the sides are raised, or they can be line segments, which we'll see here. So if you take 5, what I'm going to do to help us is kind of cover up any extra information. So for angle 5, kind of that's extra information. I do need to see that point, though. That was an M. So the vertex, these would be the sides of angle 5, and angle 5 is meeting here. The vertex would be point M. Now, the first side would be line segment MN. And the reason for that is that it doesn't extend any further. So that would be the first side. And then the second side, we do want a ray, if we can have a ray, would be ray MO. So vertex, 2 sides where they meet. And I'm not going to highlight all of them, but just to give us an idea. So then we're looking at angle 8. So we're going to find the 8. And I'm covering up an O. So the 2 sides are here. If we're looking here, I will highlight this one as well. So start it, that's the vertex for 8. That's a side, and that's a side. So the vertex here is point O. And then this side would be line segment OM or MO. The order doesn't matter there. And then this ray would be ray OP or ray OR. The third one, we have not a number, but letters, angle NMP. So remember, this has to be our vertex. So I already know the first answer. Now let's locate it. NMP is that whole angle. So this is just kind of the extra in the problem. N to M to P. And so like we said, the vertex has to be at M. So this side is line segment MN. And then we have ray MP. Or you could also call it ray MQ. So those would be the sides and the vertex for those 3 angles. And now for 3, we have to write another name for each angle. So angle 1 is here. I think I'm going to use blue for this. So if this is angle 1, its vertex is right by it, and these would be the sides. So I'm going to name this angle. The vertex has to go in the middle, OPM. MPO would also work. I want to point out this side also does go to N, so NPM or MPN would also be correct answers. And then we have angle MNO. So M, N is our vertex, M to N to O. So those are the sides. They're meeting here. So we have a number. Let's call this angle 6. You could not call it angle N just because there's an angle here and an angle here. So we can only use the vertex as the only letter when there's only one angle in the problem. Okay, question 4. Classify each angle as acute, obtuse, right, or straight. Acute are cute little angles. Right, 90 degrees. That's easy. Straight, a straight line, 180. And obtuse then would be the big angle if you kind of want to associate one word with each one. Okay, let's go through these. I'm going to highlight as we go. We have angle UZW. So U to Z to W. So we have a box in there. That means that's our 90 degrees right angle. Angle TZW. T to Z to W. Now, if this was 90 degrees and we have more than that, but not a straight line, that's our big angle for obtuse. Angle WZV. So W to Z to V. Okay, so if the whole green one was 90 and we have less than that, that's our small cute angle. This is acute. And then angle YZT, so Y to Z to T, is a straight line. So it is our straight angle, which would be 180 degrees. Okay, now this is what I said. Some of this was going to be similar to what we've already previously done. We had a segment addition postulate. We're looking at the angle addition postulate. The sum of the measures of two adjacent angles is equal to the sum of the whole angle. So again, this is the part plus part. If we add the parts, we have to get the whole thing. If we add the two parts, we have to get the whole thing. So if we look over here, we have angle, and this is a typo. This is supposed to be angle HMK. I apologize for that. So that's our first part, plus angle KMN, the measure of angle KMN. The M out in front stands for the measure. So those are the two parts. Part plus part equals the measure of angle HMN. And that's the whole thing. So if you add the two pieces, you're going to get the whole thing. So question 1 says find the measure of angle ABC. So that's our whole thing. So let's A to B to C. Let's look at our parts. So our first part is going to be the measure of angle ABD plus our second part would be the measure of angle DBC. And then the whole thing, which is what we're looking for, is the measure of angle ABC. So if we add the two pieces, we get the whole thing. Now I understand you can probably look at this problem and know the answer. However, we want to make sure we understand it before we get to the harder algebraic problems. So the measure of angle ABD, our first part, is 37, plus the measure of angle DBC was given as 21 degrees, equals, and then this is what we are looking for. 37 plus 21, 58 are labeled degrees because we're talking about an angle measure. And I'm not going to use all the letters here in number 2. The angle addition statements can be a bit much to write out, so we don't always write them out. But we do need to understand adding the parts gets us the whole thing. So it says find the measure of angle 2 if the measure of angle YJK is 160 degrees. So here's angle YJK. Now, 160 is less than a straight line. So when they are talking about this measurement, YJK, we are talking about this measurement. If we add those 3 angles up, you do not want to label the 160 here because it's the sum of these 3. So when we write this out, if we add up the parts, we have the measure of angle 2 plus 42 plus 104. So those are in this problem, we have 3 parts, equals 160, because that was the whole thing. And then we can go ahead and solve this. So kind of, are combining like terms. So the measure of angle 2 plus 146 equals 160. And subtract the 146 from both sides. The measure of angle 2 equals 14 degrees. And then, of course, you could check 14 plus 42 plus 104. If you do that on your calculator, you would get 160. Now, when we get to question 3, we're moving into a more algebraic example. Okay, so we have 2 parts. Let's see what this tells us. Find the value of x and the measure of angle ULY if the measure of angle ALY is 71 degrees. So angle ALY is the whole thing, and we're measuring it this way, and the whole thing is 71 degrees. So if we set up adding the 2 parts, the first part is 2x, plus the second part is 5x plus 8. Those are the parts, and then it's going to equal 71, which is our whole thing. Combine your like terms. And divide by 7. So this did ask us to find the value of x. I'll put a square around that. That's one of our answers. And then it also asked for the measure of angle ULY. So the measure of angle ULY. So U to L to Y is this angle here. So that's given as 5x plus 8. And then we did this with the segment addition, right? We know our x value now. We go ahead and substitute that in. So the measure of angle ULY will be 5 times 9 plus 8. And we have 45 plus 8, which is 53. And our label is degrees because we have an angle. Okay, our last angle addition problem here. Given that E is in the interior of angle HGF. So let's just start with that before we get into what everything else is. So interior means inside, right? An interior decorator is going to decorate the inside of your house. So we're going to draw angle HGF first. I'm going to draw an angle. G is the vertex. So then H, G to F. And then E is going to be in the interior. So somewhere inside, I'm going to put a point and put an E. And what I can then do is add in another ray. And so I do have two parts now. Okay, angle HGF is 16x plus 4. HGF is the whole thing. So we're going to do that little 16x plus 4. The measure of angle EGF is 110. So E to G to F is this angle, 110 degrees. And the measure of angle HGE is 3x plus 11. So H to G to E is 3x plus 11. So we have our two parts and our whole thing. So we add the two parts. So 3x plus 11 plus 110 has to equal the whole thing, which in this case is 16x plus 4. So these were our parts equal the whole thing. And we are only looking for the value of x, so we'll solve. We have like terms, giving us 3x plus 121 equals 16x plus 4. And then multiple ways to solve this. I'm going to subtract 3x from both sides. Subtract 4 on both sides. And then divide by 13. And I get that 9 equals x. Okay, so that was the segment addition, which was very similar to, or angle addition, which is similar to segment addition in that we're adding the parts to the whole thing. Next, we're going to look at our angle bisector, which is very similar to the segment bisector. To bisect, again, means to cut in half. So the angle bisector is a ray that divides an angle into two congruent angles that have the same angle measure. Now we have a way to show congruent angles. So with our segments, we had tick marks, and with our angle, we have what we call arc marks. So if you notice in these two angles, this has one and this has one arc. So those are called arc marks. And those are used to show that the angles are congruent. So since those angles are congruent, then we can say that ray YW is the angle bisector. So then let's write a statement that these two are congruent. So we have angle XYW is congruent to our congruent symbol, the equal sign with the squiggle, angle WYZ. Now, if the angles are congruent, then we would say their measures are equal. So the measure of angle XYW equals the measure of angle WYZ. So the angles are congruent, their measures are equal. Okay, let's look at our first example. We have ray QS bisects angle PQR. So just starting with that, ray QS then is our angle bisector. And I'm going to add in my arc marks because then I know those two angles have to be the same. This says find the measure of angle SQR and the measure of angle PQR. So SQR is this part. If that's 40, then this is also 40. So our first answer, the measure of angle SQR equals 40 degrees. And then using that angle addition, PQR is the whole thing. The measure of angle PQR is going to be 40 plus 40 if we add up the two parts. So the measure of angle PQR is 80 degrees. Number 2 is an example where we're going to have to draw a diagram. Ray BD bisects angle ABC. Let's just start with that. So we're going to draw angle ABC. B is the vertex. Angle ABC. Ray BD bisects. So we need in the middle, ray BD is going to be our angle bisector. And since it's an angle bisector, we can add in our arc marks because we know the two halves have to be the same. So then we are told that the measure of angle ABC, the whole thing, is 48 degrees. Find the measure of angle ABD. So we are looking for this angle here, A to B to D. So this is split in half. So we would need to take 48 and divide it in half. And each of these angles would be 24 degrees. So the measure of angle ABD equals 24 degrees would be our answer. Let's look at number 3. Ray BD bisects angle ABC. So here's ray BD. That is our angle bisector. So we can add in the arc marks, and those two angles have to be the same. So the measure of angle ABD has to equal the measure of angle DBC. The two halves have to be equal. So measure of angle ABD is given as x plus 15, and that would have to equal the measure of angle DBC is 4x minus 45. Determine the value of x and find the measure of angle DBC. So we'll start by solving this for x. Add 45 to both sides. So 60 equals 3x. And divide both sides by 3. Our first answer here is x equals 20. And then we're asked to find the measure of angle DBC. So DBC is here. The measure of angle DBC is given as 4x minus 45. So this is where we take our x value and we're going to substitute that in. So the measure of angle DBC equals 4 times 20 minus 45. And 80 minus 45 gives us an answer of 35 degrees. And this question is checkable. So if we just found that this angle was 35 degrees, we can find the other angle and it should be the same. So x is 20, 20 plus 15, is 35. So that checks. Question 4. Question 4 says, in the diagram, ray BC bisects angle ABD. Now, I didn't even need to provide that information. We should know that ray BC is the angle bisector based on the arc marks. So this has one arc mark and this has one arc mark, so they have to be equal. Determine the value of x, the measure of angle ABC, and the measure of angle ABD. So these two angles have to be equal. 4x plus 31 has to equal x plus 46. And we'll solve. I'll subtract x on both sides, giving me 3x plus 31 equals 46. Subtract 31 on both sides. And divide by 3. So it did ask us to find the value of x, so x is 5. And then we have a few additional things to find. So we'll start with the measure of angle ABC. That's A to B to C, so it's this angle. So the measure of angle ABC equals 4x plus 31. So then again, we're taking our x value and substituting that in. So 4 times 5 plus 31. 20 plus 31 gives us 51. So the measure of angle ABC is 51 degrees. Now let's check to see if we're correct. So let's plug into the other half. What is 5 plus 46? Also 51 degrees, so we know we're doing the problem correctly. And then we have to find the measure of angle ABD. And ABD is the whole thing. So kind of back to the angle addition where we'll have to add up the two parts. So the measure of angle ABD is going to be 51 plus 51. And the measure of angle ABD then is 102 degrees. And we have one last question to look at here. Just ignore this, it's not supposed to be there. We are given the information that ray QS bisects angle PQT. So this is angle PQT, just this that we're looking at. And ray QS then is our angle bisector. So right away then we know that these pieces have to be the same. We're told that the measure of angle PQT is 60 degrees. So this whole angle here is 60 degrees. Now I know more information. Because it's been bisected, we can take the 60, divide it by 2, and get that each angle here is 30 degrees. We're then told that the measure of angle PQS is 4x plus 14, measure of angle PQS. So this is 4x plus 14. Now, there are two ways to do this problem. And I don't care which way you see it. I'm going to show you both ways. The first way is this angle is 4x plus 14 and it's 30 degrees. So we could say that 4x plus 14 has to equal 30. And when we solve that, subtract the 14 and then divide by 4, we get an answer of x equals 4. The other option for solving that is if this angle is 4x plus 14, this angle is 4x plus 14, and you could do angle addition. 4x plus 14 plus 4x plus 14, and that whole angle was 60. So that concept of adding up the parts to the whole thing. And we would get 8x plus 28 is 60. Subtract 28 on both sides. So 8x is 32. And divide by 8, and you get x is 4. So it doesn't matter which way you solve it. That is x. And then the last part, and you wouldn't have to do both. I do want to point that out. It's this or this. You just have to get one of the x's. And then it wants the measure of angle SQR. So here is angle S to Q to R. And this is more numerical. This is not going to be algebra based for this problem. That is all of the straight line. Our straight angle is 180 degrees. It's all of the straight angle except 30. So I would say the measure of angle SQR is 180 and then subtract out the 30. Okay, so 180 minus 30 gives us that angle is 150 degrees. Things you could also be asked for on a problem like this would be TQR. And so kind of using what we already have, right? If this whole thing is 150 and that's 30, 150 minus the 30, this would be 120 degrees. 30 plus 30 plus 120 gives us the 180 for our straight angle. So there's multiple ways to look at some parts of that problem. So that is lesson 1.5. And then you have the 1.5 homework that goes with that. And please feel free to email me if you have any questions.